So I very warmly welcome on stage the CTO of the United Manufacturing Hub. I'm glad to have you here, Jeremy Theocharis.
Hi, are you ready?
Yes, let's make
Yeah.
Jeremy.
All right, so it's going to get boring because I read the OPC UA standard so that you don't have to. So there are, if you already know us, you know that we are not the biggest fans of OPC UA, but there's no reason to just spit anger and hate. We're going to give you 3 reasons why we think that OPC UA is not delivering on its promises. So the first reason is that the practical applications of OPC UA can be very highly unreliable. So let me take you to our journey. So we started as a system integrator a couple of years back. And when we were looking at the typical situations that we found there, like, okay, there was a company and they bought a couple of machines from OPC UA, and they thought, okay, if they tell the machine vendor to just put in OPC UA, it's going to get work. It will work. So what happened is they bought all of these machines with OPC UA, and then they didn't manage to integrate it because they realized, hey, OPC UA does not equal OPC UA. Because the system integrators and the machine vendors had no clue what it was, so it was always highly misconfigured. If there was any security in it, it would be just like some default credentials, admin. If you were to extract a lot of data points, like 10 data points per second, it would start to fail. So if you're lucky, it would just restart and the production would be shut down. If you're very lucky, what would happen is it would actually, you would needed to go there and need to power cycle the device itself. Sometimes you just, every couple of weeks, you just need to go there anyway and power cycle the entire device. So it is really complex, OPC UA, so in reality that it becomes very complex to configure it, so in the end it results being very unreliable. When we were sharing these experiences with the community on LinkedIn, so we shared it, and we had actually, there were 2 types of groups. Like the first group were the people that actually shared our pain. They were frustrated as us. They were a lot of people from the unified namespace community belonging to that group. And then there were also the ones that were seemingly unaffected. I mean, you could also divide those people into the ones that never touched the shop floor, but there were actual people using OPC UA who never had a problem. And for us, it was really strange because we just can get in our head. And over time, we realized it. What was the reason? Because it's actually switched around here. The frustrated ones, they just needed to get whatever the machine vendor was giving them. And you were now having no problems with OPC UA if you could have access to the PLCs. So the stronger you are of a manufacturer, the more standards you could enforce. And if you have access to the PLC code, then you are very likely to have no problems with OPC UA. The problem is that it is not very often the case. Most of the people, they just get a machine from a vendor and they have to live with it. Reason number 2, OPC UA is a security nightmare. So there are 2 aspects of it. The first one is security protocols, like almost like what's rule number 1 of security? Don't do security yourself. What did they do? Instead of using well-established standards like SSL, TLS, they just invented a whole security protocol by themselves. And what does it result? There is no easy-to-use reference implementation. So you cannot just use a standard SSL library to do it. Everyone who needs to implement it needs to redevelop security themselves. And because there is no reference implementation, it can just go wrong. I mean, it's not exactly like this. There is actually a reference implementation, but it has a very weird dual license, GPL and RCL, which makes it basically not usable in any commercial context. Aspect number 2, OPC UA. Oh, I'm standing in front of the screen. Okay, all right. OPC UA is typically misconfigured and it's hard to configure well. So this was actually the meme that we posted to get people where we said earlier with the frustrated users and unaffected ones. That was a meme that we posted. And I think we got over 80,000 impressions on that on LinkedIn. And I think it summarizes very well. There is this security model, like, yeah, you can make it really secure, but in the end, it's very, very hard to configure it properly. And it's not just this me, like this random dude here on stage saying that. If you take a look, like the protocol itself is approved by the BSI, the NIST equivalent, Bundesamt für Sicherheit in Informationstechnik. But if you take a look, it was approved in 2015, going 7 years more into the future. If you look at it, they're saying a secure default configuration is not the main target of the majority of the products in this server. So, which basically means, yeah, in theory, it can be secure, but in reality, it is not at all. Other studies show this is the same. 92% of all OPC UA servers had security problems, just mainly because of its complexity. And this complexity goes through this entire talk. Because reason number 3, OPC UA managed to standardize without actually standardizing anything. So let's take one example. I know it's going to get a little bit nerdy here, but I think the more technical people will understand it. So let's talk a little bit about data modeling. So there are 25 base data types in OPC UA. Sounds reasonable. There's numbers, there's strings, there's some fine-tuning you can do, but let's just assume it's fine. However, there is one data type which basically says any. So it basically means there's a data type which can be anything else. Okay, already getting complex, but we know it from programming languages. No, what's getting really crazy is that how this is modeled. Like there is a variable, you all might know it, and sometimes a variable can be an array. There's an attribute in that saying, okay, there's a number that you can set. If it is -1, then it's just a variable. If it is set to 1, then it's a one-dimensional array. If it's set to 2, it's a two-dimensional array. So it can change. But what's also really crazy is that they actually defined, I just started with this. It was like the first things that I'm coming up with. I originally want to talk about something else. But there's actually a standard that the value can be, if you set it to -2, can be a normal variable or an array with any number of dimensions. And to not even make it even more complex, there is a scalar or one dimension. The value can be a scalar or one-dimensional array, which is just like crazy. Like, why would you even need that? Why would you want to have it? So that in result, in OPC UA, it's possible to have a variable or a tag that regularly changes its shape. So it can be sometimes a variable and sometimes a 34-dimensional array with varying data types. So first element is XML file, second element is this number, third one is a string, but only sometimes. Why would you want to have that? Really, really complex and unnecessarily complex. Second aspect, that OPC UA is actually not a single protocol. It's actually over 27 different protocols. So just by looking at the standard, just the very basic stuff, like the original stuff, there's a client-server model with like 3 different protocols, TCP, HTTPS, WebSockets. There's a pub/sub model with UDP, multicast, broadcast, unicast, Ethernet, AMQP, and MQTT. And every one of those transport protocols come even with their own encoding. So actually you have, just ignoring all the security settings, session handling, you already have 27 different protocols in it. So if you now buy a machine with OPC UA, you might get any one of those 27. So it is really, really complex. So what to do now? My suggestion is to remove 95% of the OPC UA standard. I mean, there's a lot of good stuff in there, but just remove a lot of it. When I was posting it, just on Sunday, a lot of people were like, oh no, Jeremy, you're getting it wrong. What you actually need to do is you need to add to the 1,000 pages of standard, you actually need to add 500 more. Like, you have to use the companion specs, you have to use the global discovery server, you have to use the profiles. I don't know, there was also a fourth thing that we're mentioning. Like, no, you're not getting my point. It's already way too complex. Let's not add 500 pages more. What are also other alternatives? Because we have to live with it at the moment. You can also not ignore it at all, but you can have alternatives. So you can use, for example, well-established IT protocols, something like HTTP or HTTPS. It's well-established. You can use something like MQTT for pub/sub. Super simple, all the PLCs can already do it. Or you can use basically any other traditional protocol that already exists there, because how it's typically implemented is you just put OPC UA between the user and any of the other traditional protocols. So that was it from my side. If you're interested in this and hearing more about this, we have a lot of blog posts on our website, learn.umh.app. So if you're interested there, feel free to go there and check out the other articles.